Hello student, now we'll start the last topics of this chapter, that is a limit at infinity. Limit x tends to infinity, 1 upon x is equals to 0. The meaning of this is that is a 1 upon very large quantity. That is the limit x tends to infinity, 1 upon x, the value of this limit is 0, 1 upon x square, 1 upon x cube, and whatever the bigger index of this x denominator. Now we'll start the exercise 7.7. Now the first example. Evaluate the following. First is limit x tends to infinity, ax cube plus bx square plus cx plus d upon ex cube plus fx square plus gx plus h. Now in this case, the highest power of the denominator is x cube, numerator is also x cube. We divide the numerator and the denominator by x cube. Therefore, we will get divide n and d by highest power of the denominator. Therefore, limit x tends to 0. Ax cube plus bx square plus cx plus d ex cube plus fx square plus gx plus h. Limit x tends to infinity, ax cube plus bx square plus cx plus d upon x cube, ex cube plus fx square plus gx plus h upon x cube. Then we will get, that is, as limit x tends to infinity, ax cube upon x cube plus bx square upon x cube plus cx square upon x cube plus d upon x cube, ex cube upon x cube plus fx square upon x cube plus gx square upon x cube plus h upon x cube, that is equals to limit a plus b upon x plus c upon x cube plus this is, and the next is, now as x tends to infinity, all these remaining quantity become 0, that is 1 upon very large quantity, and that's why the answer is a upon e. Therefore, one upon x tends to 0 as x tends to infinity. Next is limit x tends to infinity, x cube plus 3x square plus 2 upon x plus 4 into x minus 6 into x minus 3. Divide n and d by the highest power of the denominator, that is x cube, because here is a x into x into x, 3 times it is repeated. Now when we divide in this manner, that is divide n and d by x cube. As limit x tends to infinity, x cube plus 3x square plus 2 upon x cube, and the denominator is also x plus 4 into x minus 6 into this divided by x cube. Now split up this x cube is split up like this, divide by this bracket by x, divided by x, divided by x. X cube upon x cube plus 3x square upon x cube plus 2 upon x cube, x plus 4 upon x, x minus 6 upon x, x minus 3 upon x. That is the therefore limit x tends to infinity. 1 plus 3 upon x square plus 2 upon x cube, again division, that is x minus 6 upon therefore after their division limit x tends to infinity. 1 plus 3 upon x square plus 2 upon x cube, that is 1 plus 4 upon x, x is get cancelled here. Again here 1 minus 6 upon x, and last is 1 minus 3 upon x. Bracket is completed. Therefore, the answer is, here is a 0, 0, 1 plus 0, 1 minus 0 and 1 minus 0. Overall to the denominator you will get 1. That is as x tends to infinity, 1 upon x square, 1 upon x cube tends to 0. And that's why answer is 1 upon 1. Therefore, the answer L is equals to 1. Now next is problem number 3. Limit x tends to infinity, 7x square plus 5x minus 3 upon 8x square minus 2x plus 7. Now again divide numerator and the denominator by x square. Therefore, now we divide the numerator and the denominator by x square. Therefore, it is written as, you can write now, divide n and d by x square, it is written as, now split up this, and minus 7x upon. Now these x square get cancelled, limit x tends to infinity, 7 plus 5 upon x first, 7 plus 5 upon x minus 3 upon x square, next 8 minus 7 upon x plus 7 upon x square. Now as x tends to infinity, this becomes 0, 0, 0 and 0. Therefore, which is the 7 upon 8. As x tends to infinity, 1 upon x square tends to 0. Therefore, it is equals to 7 upon 8. Now, question number 2. Evaluate the following limits. 7x square plus 2x minus 3 upon in root of x square plus x plus 2. Now the highest power of the denominator, though here is x raised to 4, but it is a square root. Therefore, the highest power of the denominator is x square. Now, see this. Divide n and d by x square. Limit x tends to infinity. 7x square plus 2x minus 3 upon x square. Now this one thing is very important, that is 7x square upon x square, 2x upon x square, minus 3 upon x square, and this divided by in root of x raised to 4 plus x. When this x square comes in the root sign, then it becomes x raised to 4. x raised to 4 upon x raised to 4 plus x upon x raised to 4 plus 2 upon x raised to 4. Therefore, limit x tends to infinity. 7 plus 2 upon x minus 3 upon x square. 1 plus 1 upon x cube plus 2 upon x raised to 4. Now, as x tends to infinity, this 2 upon x minus 3 upon x square, 1 upon x cube plus 2 upon x raised to 4 becomes 0. Therefore, the answer is, that is 7 as x tends to infinity. All these becomes 0. That is equals to 7. Therefore, the limit L is equals to 7. Now, next is number 2. Limit x tends to infinity in root of x square plus 4x plus 16 minus in root of x square plus 16. Now, to solve this limit, we multiplied is a rationalizing factor first of all. Therefore, limit x tends to infinity in root of x square plus 4x plus 16 minus x square plus 16 into in root of x square plus 4x plus 16 plus in root of x square plus 16 upon in root of x square plus 4x plus 16 plus in root of x square plus 16. That is, it's a conjugate part, rationalizing factor. Therefore, root sign will get cancelled in the numerator. That is multiplied with the positive. Here is a root sign get cancelled. That is the root of x square plus 4x plus 16 minus in root of x square plus 16 into in root of x square plus 4x plus 16 plus in root of x square plus 16. That is a minus b into a plus b. Then you will get a square minus b square. Now, see this here. Open this bracket. X square plus 4x plus 16 minus x square minus 16. Now, see this here. Now, here plus x square minus x square plus 16 minus 16 get cancelled. And in the numerator, you will get 4x upon in under root of x square plus 4x plus 16 plus in root of x square plus 16. Now, divide n and d by x. We are dividing numerator by x. That is 4x upon x. This whole divided by in root of x square plus 4x plus 16 plus in root of x square plus 16. Therefore, numerator you will get 4 in root of x square plus 4x plus 16 upon x plus in root of x square plus 16 upon x. That is limit x tends to infinity 4 in root of. Now, when this root x comes in the radicand sign, that is a square root, it becomes x square. Therefore, x square upon x square plus 4 upon x square plus 16 upon x square plus in root of x square upon x square plus 16 upon x square. Therefore, this x square get cancelled. 4 upon x, 16 upon x square plus in root of 1 plus 16 upon x square. Therefore, as x tends to infinity, 1 upon x square tends to 0. There, you will get 4 upon in root of 1 plus 0 plus in root of 1 plus 0. That is 4 upon 1 plus 1. That is 4 upon 2, which is 2. Therefore, L is equals to 2. Now the next is problem number 3. Limit x tends to infinity in root of x raised to 4 plus 4x square minus x square. L is equals to limit x tends to infinity in root of x raised to 4 plus 4x square minus x square multiplied its rationalizing factor, that is in root of x raised to 4 plus 4x square plus x square in root of x raised to 4 plus 4x square plus x square bracket complete. Then you will get limit x tends to infinity x raised to 4 plus 4x square minus x raised to 4. What about this here? A minus b into a plus b. X square and it's a bracket square. Then it will become x raised to 4. Therefore, x raised to 4 plus 4x square minus x raised to 4. Now this plus 4x square minus 4x square will get cancelled. See this here. Therefore, limit x tends to infinity 4x square upon in under root of x raised to 4 plus 4x square plus x square. In root of x raised to 4 plus 4x square plus x square. Now divide numerator and the denominator by x square. Therefore, limit x tends to infinity 4x square upon x square upon in under root of x raised to 4 plus 4x square plus x square upon x square. This is important. Now this x square get cancelled. You will get to the numerator 4. What about the denominator? When this x square will divide these terms, that is when this x square comes in this radical sign, it will become square. That is in root of x raised to 4 upon x raised to 4 plus 4x square upon x raised to 4 plus, here is not radical sign, it will remain as it is x square upon x square. Now see this here. Limit x tends to infinity 4 upon. Now the next is limit x tends to infinity in root of plus 4x square upon x raised to 4 plus 1. Now next is limit x tends to infinity 4 upon in root of 1 plus, that is therefore now the value of this limit, here is a 1, 4 upon x square plus 1, that is as x tends to infinity 4 upon x square, that will become 0, that is 4 upon 1 plus 1, that is 4 upon 2, that is equals to 2. Therefore the value of this limit is 2. Now next is evaluate the following. Limit x tends to infinity 3x square plus 4 into 4x square minus 6 into 5x square plus 2 upon 4x raised to 6 plus 2x raised to 4 minus 1. Now again, what is the highest power of the denominator? The highest power of the denominator is x raised to 6. Therefore, divide the numerator and the denominator by x raised to 6. Divide and by x raised to 6. X raised to 6. That is a 4 to the numerator 3x square plus 4 into 4x square minus 16 into 5x square plus 2. This divided by x raised to 6. To the denominator 4x raised to 6 plus 2x square minus 1 upon x raised to 6. Now separate it. Limit x tends to infinity 3x square plus 4 upon x square into 4x square minus 16 upon x square into 5x square plus 2 upon x square. This is a split up. that is x square into x square into x square, that is x raised to 6, and to the denominator also, that is 4x square, 4x raised to 6 upon x raised to 6 plus 2 x raised to 4 upon x raised to 6 minus 1 upon x raised to 6. Therefore, it becomes now separate it to the numerator. See this numerator, we have 3x square upon x square plus 4 upon x square, 4x square upon x square minus 16 upon x square into 5x square upon x square plus 2 upon x square. Now that to the denominator, 4 plus 2x square minus 1 upon x raised to 6, bracket complete. Now cancellations, limit x tends to infinity, 3 plus 4 upon x square into 4 minus 16 upon x square into 5 plus 2 upon x square, bracket complete, 4 plus 2 upon x square minus 1 upon x raised to 6. Now as x tends to infinity, that is 4 upon x square, 16 upon minus 16 upon x square, 2 upon x square, 2 upon x square minus 1 upon x raised to 6 becomes 0. That is 3 plus 0 first, 4 minus 0, 5 plus 0, and denominator will be the 4 plus 0 plus 0, and overall you will get, that is a 3 into 4 into 5. As x tends to infinity, 1 upon x square, 1 upon x raised to 6 tends to 0. Therefore, the 15 is answer. L is equals to 15, limit. Next. Now the problem number 2, limit x tends to infinity, 3x minus 4 bracket cube into 4x plus 3 bracket raised to 4 upon 3x plus 2 bracket raised to 7. Now what is the highest power of the denominator? The highest power of the denominator is x raised to 7. Therefore, we will divide numerator and the denominator by x raised to 7. Also, the highest power of the numerator is also 7. Now, see this here, as x tends to infinity, 3x square, 3x minus 4 bracket raised to 3 into 4x plus 3 bracket raised to 4, 3x plus 2 bracket raised to 7. Now divide n and d by x raised to 7. Limit x tends to infinity, 3x minus 4 bracket raised to 3, 4x plus 3 bracket raised to 4 upon x raised to 7. 3x plus 2 bracket raised to 7 upon x raised to 7. Now see this is the very important step now, x tends to infinity. We'll split up it, x raised to 7 from the numerator, as for the first bracket we'll take x raised to 3 and for the second bracket we'll take x raised to 4. Therefore, that is a limit x tends to infinity, 3x square, 3x minus 4 bracket cube upon x cube into 4x plus 3 bracket raised to 4 upon x raised to 4 upon 3x plus 2 bracket raised to 7 upon x raised to 7. Therefore, limit x tends to infinity, 3x minus 4 upon x bracket raised to 3 into 4x plus 3 upon x bracket raised to 4. Now the next is 3x plus 2 upon x bracket raised to 7, bracket complete. And now this is the easy one now. As limit x tends to infinity, 3x minus 4, that is a 3x upon x minus 4 upon x bracket cube into 4x upon x plus 3 upon x bracket raised to 4 upon 3x upon x plus 2 upon x bracket raised to 7 bracket complete. Now limit x tends to infinity. This x will get cancelled. Then in bracket you will get 3 minus 4 upon x into 4 plus 3 upon x, bracket is 2 4. And to the denominator, here is a 3 plus 2 upon x. As x tends to infinity, 4 upon x tends to 0, 3 upon x tends to 0, 2 upon x tends to and 0, and we will get the answer. Three plus 2 upon x, that is 3 raised to 3 into 4 raised to 4 upon 3 raised to 7. As x tends to infinity, 1 upon x tends to 0. Now what's happening here? That is here is a 4 raised to 4 as it is, but here is a 3 raised to 7 and here is a 3 raised to 3. Therefore, it remains 3 raised to 4 by the law of indices. 7 minus 3, that is a 3 raised to 4, and that's why you will get 256 upon 81. Therefore, the answer is, this is the answer. Number 3, limit x, that is limit x tends to infinity in root of x plus 1 minus root x. Now here we will multiply it to the numerator and the denominator by the conjugate of root of numerator and denominator by the conjugate of plus sign must be there, multiplied n and dy. It's multiplied numerator and the denominator by plus sign must be there. Had written it is a minus. Okay, I can change it. Here must be this plus sign is there. Okay, you can understand it. Now next is therefore root x plus in root of x plus 1 minus root x into in root of x plus 1 plus root x, that is a minus b into a plus b. Then it will become x plus 1 minus x, and therefore this is the, now plus x and minus x get cancelled. Root x upon in root of x plus 1 plus root x, that is limit x tends to infinity, root x upon in root of upon root of x plus 1 plus root x. Now divide numerator and the denominator by root x, that is the highest power of the denominator. Now as limit x tends to infinity, that is root x upon root x. Next is root of x plus 1 plus root x upon root x. Limit x tends to infinity, you will get 1 root of x plus 1 upon root x plus sign must be there now. I will change it. That is the root of x plus 1 upon this root, both of them, the radicand is same. Therefore, we can write in a single root, that is the x plus 1 upon x plus root x upon root x, that will be 1. Therefore, limit x tends to infinity, 1 upon root of x upon x plus 1 upon x plus 1. Therefore, you will get limit x tends to infinity, that is 1 upon in root of 1 plus 1 upon x plus 1, and that's why that is 1 upon 1 plus 1, that is as x tends to infinity, 1 upon x tends to 0, 1 upon 1 plus 1, and overall you will get L is equals to 1 upon 2. This is the answer. Now the next is problem number 4. Limit x tends to infinity 2x minus 1 bracket raised to 20 into 3x minus 1 bracket raised to 30 upon 2x plus 1 bracket raised to 50. These are the terms. Now what is the highest power of the denominator is x raised to 50. Therefore divide numerator and the denominator by x raised to 50. Divide n and d by x raised to 50. Limit x tends to infinity 2x minus 1 bracket raised to 20 upon x raised to 20 into 3x minus 1 raised to 30 upon x raised to 30 upon 2x plus 1 bracket raised to 50 upon x raised to 50. Therefore, limit x tends to infinity 2x minus 1 upon x bracket raised to 20 first, 3x minus 1 upon x bracket raised to 30, 2x plus 1 upon x bracket raised to 50. Now split up this, that is a 2x minus 1 upon x means what? 2x upon x, then you will get 2 minus 1 upon x plus 3 minus 1 upon x, again 2 plus 1 upon x. Now see this here. That is, we have split up this, that is a 2x upon x minus 1 upon x, 3x upon x minus 1 upon x. To the denominator, 2x plus 2x upon x plus 1 upon x and whole bracket raised to 50. As limit x tends to infinity, you will get 2 minus 1 upon x bracket raised to 20 into 3 minus 1 upon x bracket raised to 30 upon 2 plus 1 upon x bracket raised to 50. Now as x tends to infinity, then 1 upon x tends to 0, 1 upon x tends to 0, and that's why we get that is a 2 raised to 20, 3 raised to 30 and 2 raised to that is 50. Therefore 2 raised to 20 into 2 raised to 30 upon 2 raised to 50, then you will get 3 raised to 30 upon 2 raised to 30, and overall you will get L is equals to. Now the problem number 5. Limit x tends to infinity in root of x square plus 5 minus in root of x square minus 3 upon in root of x square plus 3 minus in root of x square plus 1. Therefore, limit x tends to infinity in root of x square plus 5 minus in root of x square minus 3 in root of x square plus 3 minus in root of x square plus 1. Multiply the conjugate part of the numerator and the denominator, that is a rationalizing factor also. That is in first case, that is we multiplied here, that is a plus sign in root of x square plus 5 plus in root of x square minus 3. And to the denominator x square plus 3 plus sn. Now what is the remaining one that we will write in the outside this bracket? That is in root of x square plus 3 plus in root of x square plus 1 upon in root of x square plus 5 plus in root of x square minus 3 bracket complete. Now you can see this a minus b into a plus b, that is a minus b in root a square minus b square upon denominator is also same thing. So radicand sign get cancelled, x square plus 5 minus in bracket x square minus 3 and to the denominator x square plus 3 minus in bracket x square plus 1 in root of x square plus 3 plus in root of x square plus 1 in root of x square plus 5 in root of x square minus 3. Now the next is, now the simplification of the first square bracket. And see this, x plus x square minus x square get cancelled. 5 plus 3, that will be 8. 3 minus 1, that will become 2. In root of x square plus 3 plus in root of x square plus 1 upon in root of x square plus 5 into in root of x square minus 3. Therefore, you will get limit x tends to infinity 8 upon 2 in root of x square plus 3 in root of x square plus 1 upon in root of x square plus 5 in root of x square minus 3. That is 4 limit x tends to infinity x square in root of x square plus 3 plus in root of x square plus 1 in root of x square plus 5 plus in root of x square minus 3. Now divide numerator and the denominator by the highest power of the denominator, that is the root of x square plus 5 means what? The highest power is x. Therefore divide n and d by x. Limit x tends to infinity in root of x square plus 3 plus in root of x square plus 1 upon x in root of x square plus 5 plus in root of x square minus 3 upon x. Therefore limit x tends to infinity x square plus 3 upon x plus x square plus 1 upon x in root of x square plus 5 upon x plus in root of x square minus 3 upon x. Therefore x square, that's this, x will go in the right hand side, it becomes x square, that is in root of x square upon x square plus 3 upon x square plus in root of x square upon x square plus 1 upon x square. This is the next split up. Now as x tends to infinity, that is a 3 upon x square, 1 upon x square, 5 upon x square, 3 upon x square tends to 0. Therefore 4 in root of 1 plus 0 plus in root of 1 plus 0 upon in root of 1 plus 0 plus in root of 1 minus 0, and overall you will get, this is a 2 into 1 plus 1 is 2. Again denominator is also 1 plus 1 is 2, 2 upon 2. Overall 4 into 1 plus 1, this is the, and next is that is equals to 4, and the limit is equals to 4, and in this way we have completed the whole chapter of this, that is the limits. Now we'll start the next chapter, continuity. Only one exercise is here also. Now we'll see in the next video. Till then, goodbye.